Welcome back from an ad break. So now we're going to jump into our next concept, where now we need to predict the name of the salt that is formed when we are reacting the acid with the metal hydroxide. So to start, we know that all acids contain hydrogen that can be donated. And then that hydrogen is always in front of the molecular formula of that particular acid. We made an example of HCl. We can also make another example of H2SO4. So this is our hydrochloric acid, and then our next one is going to be our sulfuric acid. And as you can see, in both these two acids, the H is in front of the chemical formula. So we have the H there, and then also have an H there. However, in the H2SO4, we have two of them, but then still a hydrogen. And then we need to know that to form water, the acid will always donate one hydrogen atom to the hydroxide, which is the OH. We know that the acid it contains the hydrogen that can be donated, or that it can donate. So now to form the water, the acid is going to donate that hydrogen to the hydroxide. We know that the hydroxide is OH. So when we have H and the OH, we know that that is going to give us our H2O, which is our water. Now, it's going to donate that hydrogen to the hydroxide part, or it can also donate two hydrogen atoms to the oxide. So when can it donate the two hydrogen atoms? When the acid is reacting with a metal oxide, not a metal hydroxide. Because with a metal oxide, there is no hydrogen, there's no OH. We can think of an example, lithium oxide. Lithium oxide, that's one of our metal oxide. So in this case, if an acid was to react with this particular metal oxide, for instance, H2SO4, if this was to react with this, we notice that if the hydrogen is to donate the H, one H, then the base needs to donate the OH. But in looking at this base, we do not have the OH. Why? Because this is a metal hydroxide. So then that means the acid needs to donate the two hydrogen atoms. So therefore, the H2 will be donated, and then the O will then be donated to the H2. And then that's how you're going to get our H2O, when we have the H2 and the O and the oxygen. So depending on what is reacting, or on what the acid is reacting with, it can either donate one hydrogen if it's reacting with a metal hydroxide. It can also donate two hydrogens if it's reacting with a metal oxide, because in that particular one, there is no hydroxide to be donated. Furthermore, we also need to know that the remainder of the acid becomes the non-metal part of the salt. So after the H or after the H2 were donated, so depending on what is reacting, after the H was donated or after the two hydrogens were donated, then the remainder of that acid becomes the non-metal part of the salt. So in this particular examples that we have here, we have our HCl, we have our HNO3, and our H2SO4, hydrochloric acid, nitric acid, and then we also have our sulfuric acid. So when the H is donated, there's going to be the remainder being the Cl, so that becomes our non-metal part of the salt. Now in this particular one, when the H is donated, then the remainder, the NO3, becomes the non-metal part of the salt. And then lastly, because we said in this case, the two hydrogens can be donated when that reacts with a metal oxide. Then the remainder becomes the non-metal part of the salt. So it's also worth noting that the sulfuric acid can also react with the metal hydroxide. Still, because we do know that an acid reacting with a metal hydroxide, the product will always be salt and water. So when sulfuric acid reacts with the metal hydroxide, then the H part of the acid is going to be donated to the metal hydroxide. Then the metal hydroxide will also donate its OH. But then that means at the end of the reaction, or after everything has reacted, we need to balance the chemical reaction so that we make sure that the number of hydrogen atoms on the left-hand side, or whatever metal that we have on the left-hand side, is equal to the number of the atoms that we also have on the right-hand side, because we want to always keep the equation balanced. So the number of the atoms on the left-hand side of the reaction, which is now the acid and the metal hydroxide, must also be equal to the number of atoms on the right-hand side, which is now our salt and water. So sulfuric acid can also react with the metal hydroxide, not only just the metal oxide, but also with the metal hydroxide. So with that said, we can move on to the basis of the very same reaction. So we're saying that the two parts, the metal part from the base and the non-metal part from the acid, are then going to be combined to form the salt. For an example, we said the acid is going to donate the hydrogen part, and then the remainder is going to be the non-metal part. Then now the base is going to donate the OH, or the O if it's a metal oxide. It's going to donate the OH if it's a metal hydroxide. Then the remainder is your metal. Then the remainders, which are then now the non-metal and the metal part coming from the two different substances, are going to combine and form the salt. For an example, the NaCl. Where and how do we get the NaCl? We said this is your HCl reacting with the NaOH. The product was your NaCl plus H2O. The acid donated the hydrogen, the base donated the hydroxide. Then the remainder was the non-metal part from the acid, and then the metal part from the base. Now those two, when they react, they form our salt, which is the NaCl. And then the donated particles, or the donated molecules, the hydrogen and the hydroxide, reacted to form the water, as per the general reaction of an acid and a base, that the product is always going to be salt and water. Now let's look at the bases that you're talking about here. The NaOH, as per this example, that the OH is going to be donated, then the metal part is going to be the sodium. And then the K2O, the potassium oxide, then the oxygen is going to be donated. So this is a metal oxide. The oxygen is going to be donated, then the remainder is going to be the potassium, as the K being the metal. And then the calcium hydroxide, as the OH says there, then the OH is going to be donated, the remainder, the calcium, is going to be our metal. Then aluminum oxide as well, the O, this is our metal oxide, the O is going to be donated, and then the aluminum is going to be remaining there as part of the metal. So those metals are going to combine or react with the non-metal part coming from an acid. Then after they have reacted, they're going to form our salt. What is now interesting to note about this salt is that there's an exception to the rule. So we are saying that the exception is about the metal part, which is donated from a base. In the case of the ammonium hydroxide, let's look at what happens there. The remainder of this base after removal of the hydroxide is going to be the Na and the NH4. So the ammonium hydroxide will donate the OH, and then the remainder is going to be the NH4. So what does that mean? The ammonium consists of only non-metal elements. So the ammonium salt that is formed will only contain the non-metals. For an example, we're saying ammonium hydroxide, this is the chemical formula for our ammonium hydroxide. We're noting that there's an OH that is going to be donated, and then the remainder is your NH4, and we're saying that the NH4 only contains the non-metals. Remember that hydrogen is found in group 1. Because it behaves like the elements in group 1, and those elements are metals. However, hydrogen is not a metal. It is there because it behaves like the elements in that particular group. Hydrogen is not a metal, it belongs to the non-metals. So therefore, this particular compound, the ammonium, the NH4, it is non-metal. Then looking at our acid, the nitric acid, then the H is going to be donated there, then the OH and the H are going to combine and form the water. Then the remainder is going to be the salt. So remember we said the salt is going to be formed by the metal and the non-metal part. Non-metal part coming from an acid, and then the metal part coming from the base. In this particular case, we have non-metal versus non-metal, because even the nitrate is also a non-metal. So that's the exception that we have, that the ammonium nitrate as our salt consists of only the non-metal parts. So ammonium nitrate makes an excellent fertilizer because it has a high percentage of nitrogen. So this reaction is mostly used for the purpose of now forming the fertilizer. Why? Because the ammonium nitrate, that salt, has a high percentage of nitrogen. So learners, we have gone through a variety of things now. We know that when a metal hydroxide reacts with an acid, we form salt and water. We also know that for us to be able to predict the name of the salt that is going to be formed between the reaction of an acid and the base, we know that we need to take the non-metal part and the metal part of those two substances, combine them together and form the salt. Then the remainders being the OH and the H, that's going to be forming the H2O being the water. Or sometimes when the acid reacts with the metal oxide, then the O from the metal oxide and the H2 or the hydrogen from the acid is going to react together to form the water. So the exception to that particular case is that in a case of the ammonium nitrate, we are not always going to get the metal part and the non-metal part from either the acid and the base. In this case, we are both getting the non-metal and the non-metal from either the acid and also the base. So with that said, I've said a mouthful. I hope you had as much fun as I did. Until I see you next time. Bye.